In this video, we are going to learn to find HCF by using Euclid's division algorithm. So this is a method also can be used to find HCF. So from the smaller classes, we have learned that to find the HCF by different methods like fundamental method, long division method, prime factorization method. So here also we'll find the HCF, but we'll use this method. So before understanding this Euclid's division algorithm, first we'll learn what HCF is. So the full form of HCF is highest common factor. So here first we'll learn about the factor, then the common factor, then highest common factor. Suppose we have a number, like suppose we have 20. So what are the factors of 20? So actually factor means the number by which we can divide this number and the remainder should be 0. If the remainder is 0 after dividing, that number is the HCF. So we'll see some numbers. So look here, suppose 20, we have 20. So we'll check whether 1 is a factor of 20 or not. So if we divide this 20 with 1, we'll get 2 times here. Then what will remain? 0 here. So this 0 will come here. So the remainder comes 0. So if the remainder comes 0, then this 1 is the factor. Now we will try by 2. So suppose we have 20, we will try by 2. So if we divide this 20 with 2, then we'll get 1 time first, then 2 here. So 0, so it's not divisible. So 0, since we have put down this 0 here, so 0 will be cancelled and 0 will be here. So we are getting 10 times and the remainder is 0. So since the remainder is 0, so 2 is also a factor of 20. Now we'll try by 3. So if we try by 3 with 20, if we divide, we used to get 6 times. So 3 6 are 18. Remainder is 2. So since the remainder is not 0, this 2 is not 0, so it is a positive number. So if the remainder is a number other than 0, then this 3 is not a factor of 20. So we cannot consider 3 as a factor. So 3 is not a factor. Now we will try by 4. So if we try by 4, so we used to get 5 times. So 5 times it is 20 and the remainder is 0. So if the remainder is 0, then this 4 is the factor. So 4 is also factor. Then we will try by 5. So if we divide, we are getting 4 times here, it is 20 and the remainder is 0. So since the remainder is 0, this 5 is also a factor. So 5 is also a factor. Now if we try by 6, 6 3s are 18, so remainder comes 2. So this 6 is not a factor. Then if we try by 7, 7 2s are 14, 7 3s are 21. So remainder, if we give 2 times, then the remainder comes 6. So then 7 is also not a factor. So in the same way, if we continue, we'll get 10 also as a factor of 20. So if we divide this 20 with 10, we are getting 2 times here, 20 here, and the remainder is 0. That means this 10 is also a factor of 20. Then if we divide it with 20, so 20 is also a factor, because if we divide it with 20, then we'll get 1 times. So the remainder is 0. So 20 is also a factor. So now this 1, 2, 4, 5, 10 and 20 is a factor of what? 20. Now if we try another number, suppose if we take one more number like 30. So in the same way, 1 is also a factor of 30. Then 2 is also 2. If we divide 2 with 30, then we'll get 15 times. So 2 is also a factor. 3 10s are 30, so 3 is also a factor. 4 7s are 28, but there will be a remainder of 2, so 4 is not a factor. Then if we divide with 4, we are not getting any factor. So if we divide it with 5 6 times, so 5 is also a factor. Then 7 times, 7 4s are 28, so there is a remainder of 2 again, so 7 is not a factor. Then if we try by 8, so like this, 10 is also a factor. Then 15 is also a factor. Then 30 is also a factor. So this 1, 2, 4, 5, 10 and 20 is a factor of 20. And 1, 2, 3, 5, 10, 15, 30, these are a factor of 30. Now the thing is, whenever we find common factor, so what are the factors common here? Like 2 is common, then again 5 is common, then again 10 is common, then no other number. So first we'll learn about the factors. So these are the factors we have learned, or all of these are the factors. These are the factors of 20 and that are the factor of 30. Now if we talk about common factor is CF. The common factor is 2, then 5, then 10. So these are the common factor. Now within these common factors like 2, 5 and 10, which is the highest one? So if we find the highest one, that is 10. So highest common factor is 10. So that means the HCF is 10. So this is the way we used to find the HCF. Now the thing is, we have different method to find the HCF. So this is the basic method of HCF. Now the thing is, we can find the HCF by prime factorization method. Like prime factorization method is like, suppose we have 20 and 30, then we can divide it with 2. Here 10 times, 2 times are 20, here 15 times. So again we can divide it with, if we divide it with 5, so 2 times here, then 3 times. So since these are the common number, so HCF is 2 into 5 is equal to 10. So in this method also we are getting the HCF of 20 and 30 is 10. Then again we have another method, that is long division method. So in long division method, what we do, suppose we need to find the HCF of 20 and 30. So we used to write the bigger number first. So here if we compare these two numbers, so 30 is the bigger one. Then what we do, we divide by the smaller number. So here in these two numbers, so 30 is the bigger one, 20 is the smaller one. So we divide this 30 with the smaller one, 20. So if we divide 20 with 30, we are getting 1 times. So 20 ones are 20, but if we take 2 times, it is 40. So we cannot take 2 times. So 1 time if we take, so 20 here, and the remainder is 10. Now what we'll do, the number by which we have divided 30, that number will come here. And by this 10 again, we'll have to divide this 20. So if we divide this 10 with 20, we are getting 2 times and 20 here, and the remainder is 0. So we have to keep on doing till we get the remainder as 0. So since we have got the remainder 0, now we have to see that in the last part of divide, by how much we have divided. So it is 10. So this 10 is the HCF, and we have used the long division method. So this is the long division method. Now the thing is, here also we learn to find the HCF, but by using Euclid's division algorithm. So Euclid's division algorithm is also similar to long division method. That is the reflection of long division method. So if we want to see any of the question, like in class 10 book from MBOSE, so we have question in exercise 1A. The question is, we have use Euclid's division algorithm to find the HCF of, like in number 1, it is 18 and 24. So in Euclid's division algorithm, what we'll have to do, again we'll have to compare these two numbers. So if we compare 18 and 24, we can see here 24 is the bigger one. So what we'll have to do, we have to write 24 first. After writing, then we'll have to, like, first we'll practice the long division method. So because it is a reflection of long division method, so in long division method, what we do, we used to write the bigger number and then we divide by the smaller number. So if we divide by the smaller number, we are getting 1 times here. So here is 18 and the remainder is 6. So since the remainder is not 0, so we have to keep on doing. So here the smaller one we will have to write here, then into how many times we have got here, 1 time, so 1 here, then plus the remainder is 6. So 6 is coming as a remainder. Then what we'll have to do, again this 18, the number by which we have divided, that number will come here. So in the same way, the number which is there right after the equal sign we'll have to write here. Then by which number we have to divide, that is the remainder. So this remainder will come here, and then we'll have to divide this 6 with 18. So if we divide 6 with 18, then we'll get 3 times, and 6 3s are 18, and the remainder is 0. Since we have got the remainder 0, so we have to end up here. So 6 into how many times we have got? 3 times. So 3 plus, and the remainder is 0. So we have to see that we have to keep on doing till the remainder comes 0. So since in this line we have got the remainder as 0, then we have to see that in the line where we have got the remainder as 0, in the same line we have to see how much is there right after the equal sign. So here is the equal sign, and we have to see the number just after the equal sign, and that is 6. So here we have to write that HCF of 18 and 24 is 6. So this is the way we used to find HCF by using this Euclid's division algorithm. In the same way, we learn another question that is given in the MBOSE book, chapter number 1, exercise 1a, question number 1, Roman number 5. And the question is 105 and 120. So the same method we will use, and we will find the HCF by Euclid's division algorithm. So if we compare these two numbers, again this 120 is the bigger one, so we need to write 120 first. Is equal to, then we need to write a smaller number. Then we will practice the long division method, and we will find. So 120 here, then we will have to divide by 105. So if we divide it, we will get 1 time here, so 105. Then the remainder will be 5, then 15. Then again this 105 will come here, 105. So if we divide, we will get 6 15s are 90, 7 15s are 105. So 7 15s are 105, and the remainder is 0. So till the remainder comes 0, we need to stop here. So 105 into how many times we have got? 1 time. So 1 time here, and the remainder is 15. So plus 15. Then again this 105 will come down here, 105 is equal to, then this 15 will come here, 15 into how many times we have got? That is 7 times. So 7 here, plus the remainder is 0. So 0 here. So as we have learned that the line where we get 0, in the same line we have to see the number right after the equal sign, that is 15. So here HCF of 105 and 120 is 15. So this is the way we can find HCF by Euclid's division algorithm. If you want to learn such kind of question, then please hit the subscribe button and press the bell icon so that you get notification when I upload videos.